So what's interesting about this is that it's interference limited. So I argued at the beginning that TDMA and FDMA, yeah, sure, they give you spectrum sharing with absolutely no interference, with a guarantee of no interference, but they're limited by the number of slots that they can allocate. So here, all of this analysis assumes that users are uncoordinated, they can send any bit they want, they don't have to be lined up, all that happens is you give them spreading sequences. So in other words, let's say you have a probability of error criterion of 10 to the minus 5. So as long as this IRC term is less than 10 to the minus 5, everything's fine. Your mission is succeeding. So basically all you want is that at any given time, you want some sort of control so that no more than, let's say, 10 users transmitting at the same time meet that criteria. So basically all you want is that no more than 10 users transmit at any given time. So that's how these kinds of systems are limited. And what can happen is users can turn on, they can turn off. There's no particular control required as long as sort of on average only 10 users are using the system at any time. Furthermore, if you have one more user, all it does is it degrades the error performance a little bit. So maybe you have to back off your bit or something. Any questions on that? Yes?
Is the number of users linearly proportional to the energy? So increasing the number of users will increase the energy at a constant rate?
So it's linearly proportional to the variance. Where energy comes in down here is that V is actually proportional to EV. So generally the amount of variance that each user is producing, if they're all using the same amount of energy, if they're all transmitting at the same power, then V and EV are proportional. Any other questions? Okay. Thus ends our discussion of CDMA. So we're going to move on into the final topic of the course, which is information theory.